In this tutorial, we're going to deal with nomenclature. That means it's naming the chemical formula and also from the name, write the chemical formula. And for this tutorial, we're going to focus on simple binary ionic compounds. So what you need to know is that all ionic compounds are neutral overall. So that means that the positive and the negative charges must cancel each other out. That means you have to have the same number of positive charges as there are in negative charges. So what is a simple binary compound? That means you just have one type of metal bonded to one type of nonmetal. So there should only be two elements in the chemical formula. So for example, let's go ahead and take a look at sodium and chlorine. If we look at the periodic table, you'll know sodium wants to lose an electron and chlorine needs to gain one electron to be stable. So that means that we have a charge that is a 1-to-1 ratio. So if we look at the Lewis structures for sodium and chlorine, you'll notice that sodium has 1 valence electron and chlorine has 7 valence electron. Okay, so that means when we have an ionic charge, that means that sodium is going to want to give up the 1 and chlorine is going to take the 1 electron. And therefore, we're going to have a exchange of ions. And so sodium will have a +1 charge and chlorine will have a -1 charge. They have what is called an electrostatic attraction. So the opposite charges attract. And so when we write the chemical formula, if you notice, there's only 1 sodium and 1 chlorine. The chemical formula would be NaCl. So let's go ahead and do a couple more examples. The first thing you're going to need is a periodic table. Make sure you have this out. So if you look at aluminum on the periodic table, you should already know that aluminum is most likely going to have a +3 charge. So here's aluminum with a +3 charge. And oxygen is going to have a -2 charge. I'm going to show you this two ways. One is called the crisscross rule, and the other one I'm going to visually show you how we get a neutral atom or neutral compound. So let's go ahead and take aluminum, for example. It has 3 positive charges, okay? And if we have 1 oxygen next to it, it'll only have 2 negative charges. If that's the case, that means I'm only going to cancel out 2 charges. That I have 1 more positive charge. What should I do? Well, let's go ahead and add another positive oxygen. And that oxygen has a -2. This time, I'm only canceling out 1 of those positive and negative charges, but that means I still have an overall charge of a negative because this one is not canceled out yet. Okay, so let's go ahead and draw or write out another aluminum with the 3 positive charges. 1, 2, 3. That cancels out this negative charge, but again, we still have 2 more positive charges left. Okay, so let's go ahead and add 1 more oxygen. This oxygen has 2 negative charges. Hey, look at here. Finally, all the charges cancel each other out, and now I have an overall charge of 0. Okay, how many aluminums did it take? Well, let's go ahead and count how many aluminums we have. There are 1, 2 aluminums, so I would write Al2, and there are 1, 2, 3 oxygens, so I'm going to go ahead and write O3. Okay, so this tells me how I can do it using positive and negative charges, but there's a shortcut, and the shortcut is called a crisscross rule. In the crisscross rule, we're going to just take the charges of each element, and we're going to bring it down to the other side and make that the subscript. So since we're taking aluminum to the bottom of oxygen and oxygen's charge to aluminum, you should end up with Al with a subscript of positive 2, oxygen with a positive 3 as a subscript. Hey, look at that. This and this matches. Okay, so I showed you how to do it by doing the charges, and here I also showed you the shortcut. Okay, I'm going to tell you right now the shortcut works really well. So we're going to try this with barium and oxygen. I'll do it again the same as I did for aluminum and oxygen. I will do both the crisscross and the long way. So let's go ahead and look at barium on the periodic table. You should know that barium has a positive 2 charge and oxygen has a minus 2 charge. Okay, so if we do the crisscross rule, let's go ahead and do the crisscross rule. I'll take oxygen and move it over here and barium's charge over here. So therefore I should end up with Ba2O2. Okay, so I'm going to go ahead and stop right there real quickly, and I'm going to do the positive and negative because I want to show you one other thing. If we look at barium up here, okay, let's go ahead and do its positive 2 charge, and here's oxygen, and it has 2 negative charges. Automatically I can go ahead and cancel this out. I don't have to add more barium or more oxygen so in order to cancel out, because right now it already has an overall charge of 0. So I can go ahead and write my chemical formula as BaO. Wait a minute. We are not matching. Okay, so since we're not matching, let me go ahead and tell you the next thing. All ionic compounds are written in their empirical formula, meaning that it has to be the smallest ratio. So if we take Ba2O2, we would write it to its empirical formula, so that is actually going to be BaO. So the more correct way to write our ionic compound would be BaO and not Ba2O2. Okay? Yes, the crisscross rule works, but you need to make sure that you convert whatever compound you have as far as the crisscross rule into its empirical formula. So let's practice. I will do the first 2, and then I'll ask you to pause, and then you try the next 2, and then go ahead and click play to see the answers. So let's go ahead and write lithium iodide. Lithium has a +1, and iodide has a -1. If we take the charges and do a crisscross, we should end up with Li, a 1-to-1 ratio. Okay, and let's go ahead and look at sodium now. Sodium has a +1, and sulfur or sulfide is going to have a -2, just based on where it is on the periodic table. And if we take the and do the crisscross rule, okay, oops, let me make sure that you guys see that that's a +1. Okay, if we do the crisscross rule, we know that Na is going to now have a subscript of 2, and S is going to have a subscript of 1. Now, I can't take this down further, so this is going to be just Na2S. All right, from here, I'd like you to pause the video and try the next 2 problems. Once you are done, go ahead and press play, and you can see the answers revealed to you. Here's the answers. Hopefully you get the same one. If not, you can go ahead and ask me in class when you see me next. So after you've learned how to write the chemical formula, let's go ahead and now from the chemical formula learn how to write the name. Now, it is very simple as far as naming a simple binary ionic compound. This is the reason why it's very simple. First thing you do is you take the name of the metal in the chemical formula, and then you take the name of the nonmetal and change the ending of the nonmetal with an IDE ending. So, for example, if we take Na, which is sodium, Cl, and chlorine, it would end up with having the name sodium for the metal and chloride for the nonmetal. Again, you take chlorine and change the ending with the IDE. So let me go ahead and do the next one. If we look at the periodic table, the name of the metal for RaF2 is radium. And if we take the nonmetal, which is fluorine, and turn that into fluoride. So that's just how you would name this, sodium chloride and radium fluoride. So I'd like you to try MgO and KCl. Pause the video and then look at my answers. Magnesium oxide for MgO and potassium chloride for KCl. Now you may go ahead and complete the worksheet that deals with naming and writing the chemical formulas for simple binary ionic compounds. When you are done with that worksheet, you may move on to the video titled Binary with Transition Metals.